Hello and welcome to the best practices in data organization using spreadsheets lesson as part of the computational research skills series. My name is Alex Nenadic and I'll give you a short introduction on why we are teaching you this and what you will be doing today. So spreadsheets are good for storing tabular data, that is data which is organized in a set of rows and columns. This is not the only tool we use for data storage. You can also use a relational database to store your tabular data. Or, for example, if your data is unstructured or is semi-structured, your data may be stored in text files. In this lesson, however, we are just focusing on working with tabular data, which is stored in spreadsheets. So you will definitely, at some point in your research or professional life, find yourself using spreadsheets. They're very useful and handy programs with loads of useful features. However, there are some caveats when using them, and you might have heard of some very costly and highly publicized spreadsheet blunders, and we'll talk about them in a minute. So we are going to teach you how to avoid such errors. Also, just because you can do some things in spreadsheets such as statistics and data analysis, that doesn't mean that you should actually be doing that. There are better tools for this job, and we will learn these during the course of the computational research skills series. Before we move on, a couple of links and acknowledgements. So this lesson is based on the data organization using spreadsheet lesson from the data carpentry curriculum. And we have linked to the lesson material you will be going through at the top of this slide. Data carpentry is part of the bigger international community called the Carpentries, who are teaching researchers foundational computational and data skills through a set of different lesson organizations and running 2 days hands-on and practical workshops. So we have data carpentry, which is what you'll be doing today, that focuses on giving people computational skills to handle their data throughout its life cycle using R or Python. We also have software carpentry, which is teaching people automating repetitive tasks, also programming using R or Python and version control. And we also have library carpentry that teaches these foundational skills to people in information in library roles. So let's just step back for a second and have a look at a typical research data journey and steps that we typically go through as we handle our data from the beginning to the end. So normally you start with a research question or a hypothesis that you want to check or verify by looking at some data. Your typical first step is data collection or data acquisition. Sometimes you inherit data from people who worked on the project before you, so you skip the first step. At other times, you have to start from scratch with collecting and organizing your data in a form that will be useful and usable to you and others later on. The next step on this journey is data cleaning. So if you inherit data from someone else, it may often not be organized in the right way, or it may be a collection of data from various people in different formats that are not compatible, or even if you're starting from scratch yourself and have full control over the data, you may not get the data collection and organization step right. In any of these cases, you will end up with what we call dirty or messy data, and you will need to clean or wrangle your data, which means to fix errors, reformat your data, reorganize it in a way that is more suitable for further analysis. Finally, once your data is clean, you can move on to the data analysis and data visualization steps. These two steps often occur simultaneously and are used to make sense of your data and confirm or refute your initial research hypothesis. So in this lesson, we will look into the first step only, the data acquisition step, and how best to organize your data from the beginning to make the rest of the journey easier for you and anyone inheriting your data after you. It is perfectly okay to use spreadsheet programs for each of these steps. Spreadsheet programs certainly have all these functionalities available, and we have all done it in the past. We drew charts or made some quick summary tables and calculations or did some statistical analysis in spreadsheets. However, While this is okay for small amounts of data and quick overview of data, we would advise against it for serious research. There are better tools for each of these steps on this journey, and we recommend these and teach you how to use them in other lessons. So for example, OpenRefine to clean your data, and writing R or Python scripts to analyze your data and improve the reproducibility and reusability of your research. Sometimes you will have a massive spreadsheet with 10,000s or even 100,000s or millions of rows. Selecting things manually in spreadsheet and doing calculations like that just invites trouble. Or for example, if you start doing calculations and start adding more and more formulas in a spreadsheet, you will soon end up with a spaghetti style code that you won't know where the beginning or the end is. Some calculations in your spreadsheet will depend on other calculations in different cells. Um, so that will also make your code more difficult to track and trace. Also, executing formulas in cells in a specific order becomes very important. Otherwise, you might end up with errors in your spreadsheet. So 3 months down the line, you yourself won't remember what you did and in which order. So let alone someone else inheriting your code. So your code in a spreadsheet becomes virtually unusable and very hard to reproduce or reuse. So a bit about motivation. So most researchers keep or organize their data in spreadsheets. So good practices in using spreadsheets is the foundation of good research or work practice and will save you time in the long run. Almost 90% of all spreadsheets have errors. Even the most carefully developed, tried and tested spreadsheets have errors in at least 1% of all formula cells. In larger spreadsheets with thousands of formulas, there are dozens of errors. It's just because formulas in spreadsheets are so hard to test. If this was not enough motivation for you so far, let's have a look at some widely publicized human spreadsheet blunders and high-profile stories where misuse of spreadsheets caused some pretty bad and costly consequences. I say human because it was human error to blame and not the spreadsheet program, although some of the errors can and have been caused in the past by bugs in spreadsheet programs too. So let's have a look at some spreadsheet blunders that happen in the UK, both in academia and industry and private sectors. So these and many others are published in the blog post, which is linked at the bottom of the slide. So the most publicized spreadsheet blunders in the UK are the one with the MI5, where they bugged more than 1,000 wrong phone numbers due to a formatting error in an Excel spreadsheet. There was a big blunder with London Olympics back in 2012 when a member of staff accidentally inserted 20,000 into a cell into 10,000. So the London Olympics Committee ended up selling 10,000 tickets for non-existing seats and had to absorb the cost of this. More recently, it was published by the BBC. An Edinburgh hospital had to delay its opening day because of a spreadsheet error with specifications for airflow in critical care rooms. Perhaps the most famous spreadsheet blunder from the research arena, not in the UK, is the one by Reinhardt and Rogoff, two Harvard professors, which made a mistake in their spreadsheet by failing to select all the cells in a row. So they failed to select the last 5 cells in a row, and therefore they've done some calculations in a cell, which was then used in further calculations. It was very difficult to trace. And they made some conclusions which later governments used to define their policies, economic policies, and was only found out when one of the PhD students later on, a couple of years later, tried to reproduce their results and he couldn't. And that's how they found out this mistake. So What we are trying to say is that there are better tools to do data analysis than spreadsheets. For example, you can write a code or R or Python that can be verified and checked by others more easily and extensively tested. Clearly, R or Python code is not bug-free either. Of course, there can be tons of errors creeping in, but they are more suitable for testing and sharing with others that can spot the mistakes. Also, programs tend to be linear in nature and order of execution is clear, unlike spreadsheets where execution can start from any cell within a spreadsheet. So spreadsheets are good for data storage and quick analysis or doing some summary tables or writing reports, but perhaps consider other tools for data analysis and use spreadsheets with care. So what are we going to teach you in this lesson? In this lesson, you will learn how to think about data organization and some best practices for better and more effective data organization and how to get your data into a good shape. Most of your time as a researcher will be spent in the initial data wrangling stage, where you need to reorganize your data in order to perform a proper analysis later. It's not the most fun, but it's necessary. And we are focusing on helping you reduce the time spent on data wrangling by organizing your data properly from the get-go. With this approach, you can better format your current data and plan new data collections so less data wrangling and cleaning is needed in the future. What are we not going to teach you in this lesson, however, is how to do statistics, how to do formulas, how to do plots and graphs using spreadsheets. There are many good tutorials available on these topics online and about functionalities of spreadsheet programs, so you can find those easily. So for this workshop, you will need a spreadsheet program and some messy data that we have available for you to play with and which is linked from the lesson material. There are also many spreadsheet programs available. For example, you can use LibreOffice, you can use Microsoft Excel, Numeric, OpenOffice, Google Spreadsheets. While they may differ slightly in available functionalities, in general, they can all be used to perform similar tasks on tabular data. This lesson uses Microsoft Excel in the examples and exercises. Although it is not open source software, it is widely available and used, and often spreadsheet errors occur due to some peculiarities of Excel that users are not aware of and that we want to draw your attention to. So the data used in this lesson comes from a real-life project observing a small mammal community in southern Arizona, the US. This part of a project is studying the effects of rodents and ants on the plant community that has been running for almost 40 years. And the rodents are sampled on a series of 24 plots with different experimental manipulations controlling which rodents are allowed to access which plots. So this is a real data set that has been used in over 100 publications. For the purpose of this lesson, however, the original data has been modified and simplified, and also we are only using a subset of the original data. However, you can download the full data set and work with it using exactly the same tools we will learn here. So this simplified teaching version of data is available from Figshare, from the Portal Project teaching database, and it's linked from the lesson website. So throughout the lesson, you will work to restructure data and get it into a better shape. So here is the brief outline of what you will be doing today. We will cover the following 5 topics. So the first one is what are best principles for using spreadsheets for good data organization and how to format data in spreadsheets for effective data use. Next, what are some common mistakes with formatting data in spreadsheets and how to avoid them? After that, some peculiarities of storing and handling data in spreadsheets and how to avoid mistakes. Also, we will look into validating data on input for basic quality assurance in spreadsheets and to limit incorrect data on entry. And finally, we will look into exporting data from spreadsheets in a way that is useful for downstream applications or publications. And with that, I just want to wish everyone good luck with working through the material, and we will see you a bit later for the question and answer session. and some discussions.